Where, Brody?
Oh, no, it's just that number 4 on ours
Has an open dot there, doesn't it?
So it wouldn't be...
So the only thing that would change there, since you have an open dot there, is that is not equals. That is just less than, and that is a round bracket. That's what changes on yours. Are we good? Ask now, because we're moving forward. Going once? Just say a number, Braden, and I'll go over it. Okay. Domain. Go to the lowest x value, which is the furthest one on the left. 1, 2, 3. Negative 3. The dot is colored in, so negative 3 is included. Then go along until you run out of graphed line, which is right there at 0. The dot is colored, so it's included. Negative 3 less than or equal to x less than or equal to 0. Square brackets because there's equal thens.
Oh, the 0 looks like a 6, so I'm very confused.
Oh, I see. Okay. And then range is the same thing. Yes? Alrighty then. Here is the next page. Also done with both. Except some of them were weird. Like number 1 here, you couldn't use interval notation. You had to list it because there's no line. So all the x values go first, then all the y values in numerical order. No repeats. Now what you have to remember here is this -5, -5 is not a point on the graph because that is no longer an ordered pair, is it? That is just a domain value and a range value. They are not an ordered pair. Does everybody understand that? All these two lines mean is that the lowest x value is -5 and the lowest y value is -5. But there is no point on the graph that is -5, -5. Okay? Where? Well, the range value, you mean? The domain value? Well, domain is the x values. There is the lowest one at -1, 2, 3, 4, 5. There is the highest one at 0. Since it's an open dot, you have to have a round bracket or just the arrow. I can't stress this enough, ladies and gentlemen. This is why I showed you in the notes as coloring along the lines. Now, of course, in 3, my biggest value is 6, and then it just goes down forever because of that arrow. So that means all my x values are less than or equal to 6. If you left it as a dot, then it would be 1, 2, 3, 4, 5, 6, 7, 8. It would be -8 less than or equal to x less than or equal to 6. And -8, 6. If you left it as a dot. If you left it as an arrow, which I thought it was pretty clear that it was an arrow, but I don't remember what I told you guys because I changed some of these, right? That's why you're supposed to do it when I do it on the board. Maybe I made one of those an open dot. I don't know. This is an old version of it. I just didn't want to write all this out and take all that time. If the drawing is different from what you have, then just make the appropriate change or ask. So before I go any further, obviously, are these the same open dots that I gave you? Okay, then. So remember what this means? X is all the real numbers. That's what that means. It also means you could write it this way. Negative infinity, positive infinity. You could have written that. Are we good? Everyone is good? Go back to where, Gersil? Yes. Of course I can. But it is recording, so it's going to be recorded until infinity on YouTube. In 1,000 years, when they go, if there's humans still around, and they dig up YouTube headquarters and find the servers and somehow manage to power them up, they will find all my knowledge. Thank goodness. No, because what they will do is say, what another idiot. What? I have a ball of plastic wrap that I am playing with because there are some things I'm immature about. One of them is I still fidget with things. Not a lot of things I'm immature about. That's not true. There's a lot of things I'm immature about. But this is one of those things that my parents could never get out of me, no matter how many times they yelled at me. So now we move it along to page 86. Now, there is a crap ton of math going on in this first question. Half of it you already know. Half of it is new. So let's talk about the stuff you already know. Every single one of you, be it by yourself or with the person sitting next to you, should be able to fill in all of these blanks already, just from reading the graph, because you are good at reading graphs, because you read them in a lot of other courses. All of you should be able to do this side. Go. The new stuff is coming up afterwards. Oh, look, now it looks like the golden snitch. The golden snitch. See, it even flies like the golden snitch. All right. Okay. What's the independent variable? Muscan says depth. How many people agree? Gersil disagrees. Muscan, why do you think it is depth? Keep saying what you're going to say because you're going to change your mind. How deep you go depends on what? How long you're underwater. So what is the dependent variable? Depth. So what is the independent variable? Time. Now, let me put this to you another way. You're the scuba divers. I'm the guy on the boat. Is time passing for me? Have I gone underwater? No. Everybody understand? Independent variable is the one that's the same for everyone, whether you're part of the graph or not. Everybody cool? All right. How many minutes did the dive last? 30 minutes. Good. Somebody always says 28 because that's the last number they see without recognizing each square is worth how many minutes? 2. Good. At what times did the diver stop her descent?
14.
She stopped at what times? She stopped from 4 to 8 and 10 to 14. How did you know? Right. Time moved on, because does time ever stop? Time moved, but depth didn't. Excellent. What was her greatest depth? 20 meters. How long did she spend at that depth?
4 minutes.
Oh, everybody, so good. Domain and range. What is the domain?
Is it the depth?
Domain is the set of values, set of elements that make up the independent variable. 0 less than or equal to what? Time, because that's our domain here. Less than or equal to 30. What's the range? 0 less than or equal to depth. Less than or equal to 20. Well done. All right, that's all the stuff you already know. Now let's talk about a few things. 1, does this graph accurately depict what actually happened? No. What does it depict?
How long she was, where, what depth she was at what time.
Yes, it depicts the data. Because in real life, don't draw this. In real life, the boat's up there, yes? And the scuba diver
It's dead.
swims down. So if it was a drawing of real life, this would be reversed, yes? Excellent. Okay. So that's the first lesson here. And this is all going in this space over here. 1, graphs show data, not a picture of real life. Right? If I jump out of a plane without a parachute, I fall to the ground, yes? But what is happening to my speed the longer I'm falling out of that plane? It is increasing, yes? So even though I'm falling out of the plane, my speed over time is going up. Even though my height is going down. Everybody understand? Okay. Yes, your speed does flatten out at some point, but that's not important for the discussion. Now we're going to talk about some new stuff, okay? You all would agree that this graph is divided into how many different sections, would you say?
2, 3, 4.
You just keep saying numbers. Just
Counting.
6?
Yes.
6 sections. How do you figure? The graph right here. We're still talking about the scuba diver. You say 2. Okay. I hear 3. I would say 4, actually. I would say
I was close.
there is 1 section. Yes? And then she chills for a while. She sees a cool jellyfish or something. Right? Yeah. There is a second section. Yeah. Actually, that's not bright enough. I want to use bright colors. Really? The orange was better? Okay, just say so. Jeez. 1, 2, 3, 4, and then I would say there's a fifth. Actually, I would say 5 right there. Everyone agree?
Yeah.
Now, on the yellow, the orange, and the red line, what is changing? Only depth? Depth and time, yes? So, on that yellow line, there is the depth. You can't see that yellow? What a pain. Okay. On that yellow line, there are 2 things that are changing, yes? One is depth, which is a distance, agreed? The other is time, which is a time, agreed? Where in your lives do we ever see a distance divided by a time? You're on the right track. 100 meters is a distance. What? When you're moving. Like in a car, yes?
Yeah.
How fast are you allowed to move in a car on a city street?
50 miles per hour.
No, 50 kilometers per hour. Everybody understand? This is called a rate because we are doing a division of 2 things. Everybody cool? Now, in this case, it's distance divided by time. It's giving us a rate, like driving a car, 50 kilometers an hour. How far do I go in 1 hour? 50 kilometers. How far do I go in 2 hours? 100 kilometers. How far do I go in 3 hours? 150, right? No. Everybody understand? That gives us a rate, the rate that we know of, right? We all understand kilometers per hour, okay? Now, let me ask you this. Can you ever have any other kind of rate? Yes, as long as you divide the change in the, I gotta slide this over a little, sorry everyone. As long as you divide, in math and physics, a triangle like that means change. If you divide the change in the dV over the change in the IV, you get the rate for that graph. Everybody understand? Braden, do you need to leave? Because you're pissing me off. And I'm being really nice about it in hopes you would figure it out. Everybody understands that making that division will get me a rate, just like in kilometers per hour. So let's look at this situation. How far did my dependent variable change here? 12. How far did my dependent variable change here? 4. So what is the rate of change for the yellow section of the graph? 12 over 4, correct? Right? Now, would we ever say I drove at a speed of 200 kilometers per 4 hours? No, of course not. What do we always say? We break it down to 1, yes? 50 kilometers per 1 hour, right? So, this is 12 meters in 4 minutes. So how many meters did she move in 1 minute? 3. So the yellow part, she is moving at 3 meters per minute. Everybody cool? You do it for the orange one. How far up did she go and how far that way did she go? Orange is pretty visible, so I'm going to write it over here. How far up did she go? 8 in meters. And how far? 2 minutes. Now, would we ever say I went 8 meters in 2 minutes? What would we say? 4 meters per minute. Yes? Everybody cool? Now what's different about the red line? She's ascending. She's going back up, right? So, what is this number here? This is tricky. I went up 12. What is happening here? Negative 20. Is time changing? What's my time? $16, right? So in red, it's negative 20 over 16. Now, we don't like that. What's that? What math did I do here? 8, 2 to get 4. 12, 4 to get 3. What do I do here? Divide. No. Divide by 16, right? 8 divided by 2 is 4. 12 divided by 4 is 3. So I need this to be at 1 minute. So I got to do negative 20 divided by 16. What is it? Shouldn't take that long to do negative 20 divided by 16. You're all holding on to calculators. Why are you in math class without your calculator? That's silly. What is it? Of course it is. Negative 1.25 meters per minute. Now, why is it negative? Because it's reversed. It is not up and down. It is not depth, and positives and negatives in here just mean directional changes. Everybody cool? So she descended at 3 meters per minute. Now you could argue, since she's going down into the water, that these are the negatives. The negative 3 and the negative 4, and that's positive because she's coming back up. But it doesn't matter. Everybody cool? Now, which of those is the highest rate of change? Yellow, orange, or red? Orange, because it's 4 meters per minute. Now look at the 3 lines. How would you describe the orange line compared to the other 2? Steeper. The steeper the line, the faster the thing is changing. Everybody understand? All right, let's do some more math. Slide down to number 2. This graph shows the volume of water in a watering can, right? So, it's split into 3 sections, yes? Right? We can see that, can't we? Okay. So, what is happening from A to B in this watering can? From A to B, it stays the same? Right. We added water to the can. Now, if you wrote that and I was giving you a grade 1, 2, 3, or 4, what do you think I would give you for that? 1. Because that's what's happening, right? That's it. That is the lowest amount of information you could give me, right? How could we make it a 2? No. We're only talking about A to B right now. How would I make A to B a 2? Okay, so Emma says, how much water did I add? Right, so we added, so I'm going to make, in red, I'm going to write what we added. We added 0.75 of a liter. That'd get me to a 2. How could I get it to a 3? We could add the time. We added 0.75 liters of water in how long? To the can in 30 seconds. That's a 3. How could I make it a 4, do you think? Hint, it has to do with what we just did. Figure out the rate. What is it? 0.75 over 30 seconds, yes? Now, let me ask you this. Would you ever say that? I drove 25 kilometers in half an hour. Is that your speed? Is that what's up on the speed limit signs around here? 25 per 30 seconds or 30 minutes? No, what should it be over? It should be over 1, yes? Now, would we be better to make this in 1 second or 1 minute? 1 minute, because we can do it in our heads, can't we? What do I have to do to 30 seconds to get it to 1 minute? Multiply by 2, right? So what would I have to do up here? So what is my rate of change there? Per minute. What do I do there? 1.5 liters per minute. I should have done that in purple because that's the mix. Does everybody understand how I would grade a question like this? What's written in black? What's happening? 1 out of 4. Great. You can read a graph. Add the red and the blue. Right? 2 out of 4. Right? Or add the red, 2, add the red and the blue, 3. Actually tell me the rate, 4. What if you left the rate like this? Do you think I'd give you 4? It's right. But is it? No. To get that 4, I want to see it done properly. Everybody agree? Okay, what's happening from B to C? The water stays the same. Now, what could actually be happening there? Because I say I want to know what's going on. So, okay, I picked up the watering can. I started filling it up. What's going on from B to C? I carry the water can somewhere. Right? The volume doesn't change. Time moves on because I am carrying the watering can over to the flowers. Everybody good? 4 out of 4. No problem. B to C. I'm walking to the flowers. Whatever. Right? What's happening from C to D? And just give me the 4-point answer. I empty the water. I empty the whole can. At what rate? How do I do that? How far down did I go? $1.75 in how much time? 20 seconds, right? How do I make that a minute? What do I got to multiply by? So I got to multiply that by 3. So what is it? Somebody get their calculator. You guys grab your calculator for doing 2 plus 6, and you don't grab your calculator for doing 1.75 times 3? 5.25 liters per minute. Is that faster than I filled it? So the line should be steeper. Is it steeper? Good job. Okay? Now, of course, what really happened here was my sister, when she was a kid, was sunbathing in our yard. And I snuck up behind her with a watering can and dumped it on her back. Because that's what big brothers do. It's how we show our love. All right, is everybody good? Okay, now, turn on to page 87. Listen to me carefully, those of you that are unable of hearing this instruction. I want you to attempt to draw this graph based on these rules on this axis. You're going to screw it up. Most likely. So how should you draw it? In pencil. Everybody, you can work with your friends. Go. Of course, it's bathroom. Ladies and gentlemen, do not bother looking at what I am doing. Just continue to work on yours. Okay? if you're still sketching, that's cool. Just have a quick look up. Why have I set it up with time down here and distance over here? Time is our independent variable, okay? And generally speaking, we put the independent variable on the x-axis, almost always, okay? Has everybody gotten it, something going for most of it yet? No, it should be maybe, Braden, right? This is your first attempt at doing this. You should feel a little about it. And I guarantee you there's a part that you guys are going to make a mistake on. And that's cool. I want you to make that mistake. It's leading to my next teaching point. When you feel you are as far as you are comfortable going, like you're at the I don't really know what to do next, just stop. Addison, yes?
Is he going at a constant speed of 140 kilometers?
I know what you're asking.
Is he always going at that speed? Because it doesn't say he drives 50 kilometers back towards home, but what speed?
I know. We're going to talk about that. That's something that's weird here, right?
Is that portion that many kilometers during the 2 hours, or is that after the 50 kilometers?
A, B, C, or D?
It's C and D.
Right. So he drives 50 kilometers towards home, stops, and then continues driving.
For 2 more hours?
2 more hours. Yes, for 2 more hours. All right. So that you most of you are at puzzling over C and D now, yes? All right, well, let's talk about the first one, which I'm drawing in red. First 2 hours of his trip. So his trip starts at what time? 0. Excellent. And for the first 2 hours, he goes 140K, yes? So I have gone up in 20s, agreed? So 100, 120, 140, yeah? 2, 140. Is everybody happy with that? I took 2 hours, I went 140 kilometers, yes? Now, since I went at a constant speed, I'm going to draw a straight line. Because a straight line means constant. Now, is that really possible? No. Can you drive out of your driveway and immediately be going 70 kilometers an hour? No. And can you maintain 70 kilometers an hour somewhere? No, there's stops and starts, right? But let's pretend that Jack lives in the middle of Alberta, where there is no such thing as a road that turns, there is no such thing as a hill, and you can drive for days without a stop sign. He gets out of his driveway and pins it to 70. Everybody okay with that? Addison.
So, don't you need to times 140 by 2?
No.
Running for 2 hours.
In the first 2 hours of his trip, he travels 140 kilometers in 2 hours.
Oh.
So what was his speed? His change was 140 per 2 hours. But we don't do it that way. What is it really? 70 kilometers per 1 hour, right? Okay, good. So everybody's okay with the first one? You should have a straight line from 0 out to 2 and up to 140. Everybody happy? All right. What happens then? He arrives at Grandma's house. What happens? So does his distance change? Does time stop? No. Does time ever stop? No. So time goes for 1 hour till 3. Is everybody cool with there? Now here is where half of you are going to make your error because of what the page says. He drives 50 kilometers back home. How many of you went that way? Be honest. How many people went that way? Okay. We're going to talk about that in a minute. All right? Because that's not okay. But we're going to talk about why in a second. I'm going to use green for the right drawing. So 50 kilometers back towards home, but stops 30 minutes for supper. Now, as Jack says, we have no idea how fast he's driving, do we? Because it just says he drives 50K. Right? So I'm going to go ahead and make an assumption, because I don't have data for it, that he's going to keep the same speed here. So 50K. So if he goes 70K in 1 hour, but he's only going 50K, is my green line going to get all the way out to 4? Yeah, exactly. But it's going to be at the same slope, yes? So I'm going to go up for 50K. So for me, that's 2 dots, right? 2 and a bit, because I'm going up by 20s, yeah? So out to just before 4. And it's the same slope as here, yeah? Then what do I do for half an hour? Or what does Jack do for half an hour? He eats. So what happens to his distance? Stays the same. Does time stop? Does time ever stop? No. So we go out half an hour till like 4:15, right? Everybody cool? Yeah? And then he's going to get the rest of the way home. Now he drove 140 to visit Grandma, yes? So to get there and back, it's going to be how many kilometers? 140 there, 140 back, 280. So my graph needs to go up 200, 220, 240, 260, 280, 300, right? Now, I've already gone 50K towards home, and it still takes me 2 more hours to get there. Is my line, my finishing line here, going to be steeper or shallower? Shallower, because I am using less distance in more time. So I'm going to go a shallower line for 2 more hours till about 6:15, and that's going to be the pink line, till about 6:15 up to 280. Everybody cool? Now this is what we call a distance time graph. Because it is measuring a total amount of distance traveled. His car, if he jumped in his car and he had the odometer set at 0, when he got home it's going to say 280, isn't it? Because he drove that car for 280 kilometers. Does everybody understand? Okay. So now in this space down here, this white space right here, distance, and I'm using the same blue I used up there, distance is scalar. And that's a new word for you, unless you've done some physics in Science 10, if you're in it right now. Scalar means it only has a magnitude or a size. Here is what I mean by, I'm going to do them both. Now, some of you, and I'm going to change shades, drew it this way. Down, stopped, and then I'll change shades of pink. Down till you got, down till you got home, right? Because some of you turn back towards home, right? Be honest, it's okay. This is distance time. This is what we call displacement time. And I'm going to talk about why right now. Class is about to end. You're not getting any homework tonight, but I want to try and get through this. Displacement. I put too many E's in there. Displacement is a vector, which means it has a magnitude, which is a size, and it has a direction. Okay? And that's where we're going to stop today, because to explain these, I actually need to get up and move around, and you're going to forget, so we're going to talk about it tomorrow. See you later. Goodbye. Got it all done before the bell stopped ringing. You guys have a good day.